In our world today, it is important to find ways to produce sustainable and renewable energy that is environmentally safe to use. We're dealing with a multitude of environmental problems here and nobody would want to make it worse. One of these sources of energy that scientists have discovered is nuclear energy. Where did they get this energy from nuclear fission or nuclear fusion? But let's focus on the latter. Nuclear fusion releases heat and its effects simply fell from the sun, which fuses hydrogen and helium. From this we get another source of renewable energy, solar energy. First, there are elements and compounds involved in the reaction. Hydrogen would fuse together to form helium and high amounts of energy, which is the same thing that happens to the sun. However, there are different reactions that involve the isotopes of hydrogen, namely deuterium and tritium. First, we have the proton-proton chain, where a deuterium atom combines with a proton to form helium-3. When two helium-3 atoms combine, they stick together, decay, and they form helium-4. The second reaction is the deuterium-deuterium chain, where two deuterium atoms combine and form helium-3. Lastly, you have the deuterium-tritium chain, where they form helium-4 and produce energy. The deuterium-tritium reaction, or DT fusion, releases 17.6 MeV compared to the 200 MeV produced by U-235 fission. Deuterium is very abundant, as it is naturally found in seawater. Tritium, on the other hand, can be found in minimal amounts, usually through cosmic rays, and is radioactive, having a half-life of 12 years. In order for nuclear fusion to happen, there are certain conditions it has to follow. The hydrogen atoms are known for having positive charges which allow them to repel each other. However, given high temperature, it will give them the ability to overcome the repulsion. A temperature of 100 million Kelvin is required for this to happen. Now that's 6 times harder than the core of the sun. The hydrogen atoms are now turned into plasma in which they are now rapidly free to move about. The second condition would be high pressure. High pressure is needed to combine the two positive atoms. Another requirement is that they must be 1 times 10 to the negative 15 far from each other. Another condition would be confinement. When atoms are combined with a magnetic field, it allows the atoms to move in the required spiral motion. The last condition would be fuel. Deuterium can be extracted from seawater. Tritium can be harnessed from lithium in land deposits or seawater. The massive gravitational force of the sun allows nuclear fusion to easily happen. However, it is much harder to produce it here on Earth. Fusion fuel, which consists of different hydrogen isotopes, should be kept in extreme temperatures, kept dense, and kept confined. Technology has also made nuclear fusion possible with ion and laser beams. Nuclear fusion is an exothermic reaction, meaning it releases heat. Its rate of reaction can be calculated with this equation. However, its exact rate is dependent on the relative velocity and cross-section. How about the nuclear fusion's effects on the environment? As a matter of fact, nuclear fusion is okay. It does not release radioactivity or radioactive products because of its controlled parameters or conditions, as confirmed by CAFP. Nuclear fusion also doesn't release greenhouse gases or atmospheric pollutants. Aside from these things, it does not contribute to climate change. The fuel consumption is extremely low. It only consumes 100 kilograms of deuterium and lithium per year to be able to produce 7 billion kilowatts of energy. On the other hand, fossil fuel plants consume 1.5 million of coal. Nuclear fusion has given humans many benefits. On the top of the list would be the sun. Without nuclear fusion, no star would come to exist. For the maintenance of life, nuclear fusion plays a big part. Another importance of nuclear fusion is that it is a source of energy. Our world needs sources of energy to power machines and appliances. The biggest nuclear fusion research project was done by ITER. They did this in France in order to generate 500 megawatts of energy. Although nuclear fusion has many benefits, it may also be used as a weapon. They are called thermonuclear weapons or hydrogen bombs. These are the only countries that have tested hydrogen bombs. Cold fusion is the fusion of atoms at temperatures close to room temperature. However, scientists were not convinced of this idea. There you have it, nuclear fusion 101. Thanks for watching!